Hello everybody, thank you very much for coming, especially when Brendan Greg's presenting over there. What I'm going to be talking about today is basically the last 3 years of my life, or to put it another way, what I wish I knew when I'd started testing storage systems 3 years back. I'm going to a quick intro about me, but not too much, because let's face it, you don't know me from anyone. So, quick talk about what the place I work for, Wellcome Trust Sanger Institute, is and does, and why we need to do storage testing at all, why we can't buy it off the shelf. And then I'm going to some of the lessons I've learned, tips and tricks that have come out of that, and then just wrap up at the end. So, Sanger Institute, funded by the Wellcome Trust, mostly fully funded by the Wellcome Trust, about 90%. I thought it was fully funded, but it turns out we get about 90% of our funding through the Wellcome Trust. What that means is about 10% comes from industry, collaboration, outside grants, that kind of a thing, which turns out to be an increasingly big deal for us in terms of how we collaborate. So it's a fairly large institute. It's on the same place as the European Bioinformatics Institute, which is an equally sized place. So we've got a lot of people on the site, and we share a data center with the EBI. We have 4 data centers on the same site. So Sanger, for people that don't know, was part of the was part of the quest to sequence the human genome, which, if people don't know about this, was a bit of a race. Some private companies started sequencing the human genome and patenting it, and basically the Wellcome Trust said, "Oh, we're not having this," and put some money out for people in the UK to do the sequencing. They started doing this. Originally, they were supposed to be doing 1/6, and they were getting on so quickly, and other people were dropping behind or not able to catch up. And the Wellcome Trust said, "Okay, more money," and they went up to 1/3. So there's a lot of things being learned at the time, a lot of data being generated. Basically, it was all fairly new, cutting-edge stuff. What we've changed over time, now that we've sequenced the human genome with partners, is a lot of bioinformatics and genome research based on that information, sequencing more people, greater scale, from 1 person to 10 people to 10,000 people, and up and up and up. Okay, so by the way, any liberal arts majors here? Okay, I wasn't expecting any, so welcome, well done. So you might actually recognize who this is. This is my namesake, John Constable. He's a painter famous for landscapes in the UK. If you're not from the UK, you likely may not have heard of him, or a liberal arts major, hence why I asked. So in the UK, this is great. It means that I'm pretty much ungoogleable, because John Constable, the painter, comes up first. It's fantastic. Coming to the US gets a slightly different thing, because constable also means policeman. That's not as much the case in the UK, but if you're from, in the US rather, but if you're from Canada, then I think you probably get a similar kind of thing. So I've been working at Sanger about 3 years. I've been in IT over 20. And as I say, I'm going to be talking about all the things I've been doing over the past 3 years or so. So what I've been doing, particularly, it's about half of my job. Half of my job is typical system administration work, managing storage systems, more recently managing the high-performance compute infrastructure at Sanger, one of the team, I should say. The other half of my job is pretty much doing evaluations on different vendors' storage equipment. So why we need to do this, I'm not quite sure how well this comes up, but basically this is the rate of yield of data that comes off the sequences. Now, there's a couple of interesting things that don't immediately come out of this. The first thing is that this is the rate of data that is generated by the sequences, and it's fairly, linear curve, but we don't ever throw any of it away, because quite often you can't replicate the sample. So the scientists literally don't allow us to throw any of this away. So all of this piles up. Like, when your mum asked you to tidy your room, you didn't. Week after week after week, the rubbish got higher and higher and higher. And this is exactly the same thing. Only scientists, even more so. So that's fairly scary in itself. This graph also doesn't really show what actually was happening at the time, which was there have been new developments in sequencing going on every 3 or 4 years. And what that meant was it would be ingress rate, oh, new thing, bang. And we'd move from having a small amount of data coming in to a much larger amount, in some cases in 3 weeks. The scientists were very excited, could buy new sequences, went and bought new sequences, plugged them in, and told us, oh, they're arriving tomorrow. We can put them on the network, right? We can put the storage system in, right? Which is fairly normal, I guess, but not so when they generate terabytes worth of data at a time. having to scale up to that is quite scary. So Sanga's a charity, and what this means is that while I'll be talking to you about storage systems, I can't be mentioning particular names, partly through to NDA, and partly as well because Sanga cannot, as a charity, endorse particular brands, companies, and what have you. So if you want to know particular horror stories, catch me afterwards, but I can't stand up in front of people, especially if it's being recorded, hi Mum, and to go particular vendors. So one of the other challenges we have is that our users are biologists and bioinformaticians, which means that UNIX and that kind of thing isn't really their speciality. They do a very good job, to be quite frank, of getting up to speed with a lot of this, particularly when it comes to managing our cluster compute farm and working in it and things like that. But that's not their skill set, that's not their area of interest. Managing that and their understanding of the data and how it's handled, things like that can be interesting. Overall, we've got about 50 people doing IT, but not all of those look after the storage and HPC. We've got about 12 people doing that, managing about 20 petabytes. So we have our funding rounds every 5 years or so, and at the beginning of this, we need to plan how much we're going to be needing, both of money and also in terms of, bless you, also in terms of how much money we're going to need to do this, which of course is a fantastic thing to plan 5 years in advance, right? In year 5, we need to be spending this much on storage. I mean, 5-year plans generally are a bit scary. Trying to do that with money when you have to commit it up front, also a bit scary. But what comes in with that is that we're increasingly having to, sorry, I'll rewind slightly. When we go to the scientists and say, okay, what do you plan to do over the next 5 years? They come up with some fantastic figures. And then we say, okay, let's kind of refine this a bit. What do you mean by that? How many sequences? How much research are you going to be doing? Looking at the metrics, how much compute farm do you need? How much do you think it's going to scale? Things like that. And they came back and think, okay, we think by the end of the quinquennium, at the end of the 5 years' time, we're going to need about, have about 70 petabytes worth of data. And that's compared to the 21 odd petabytes we have now. So, hands up anyone who thinks we're going to be quadrupling the number of IT staff we have managing that. Yeah, it doesn't count. You work there. I mean, you like that to be the case. We'd all like that to be the case. Not so. So in best management terms, we need to work smarter with this. We need systems that will scale. We need systems that we can manage with the same people we've got. The other thing that's interesting for us is that the scientists not only won't let us throw anything away, they want to be able to compare it. They want to be able to take this 10,000 genome set and compare it to that 10,000 genome set. And that was interesting. Let's do all those again, and more, and a number of different times, different algorithms. Keep doing this. So we can't actually use tiered file systems very often. So all of this data is running on a spinning disk. When you look at CERN and people like that, quite often they've got a lot of this data on tape. And that's expensive and hard to manage in and of itself. But we need to keep it on a spinning disk because they need to keep accessing it. And we have this wonderful case, a little while back before I started, we had this wonderful HSM system. It moved the data up and down between the tiers so we could have, tape, spinning disk, more expensive disk, all that kind of thing. Excellent, all worked fantastically. But it had one flaw. It told the users when the data was going to be migrated to a slower storage. So can anyone guess what they did? Yeah. Yep, touch. Yeah, and they went around and touched every single file. That didn't work out so well. So of that, we have 7 petabytes of the pretty much what I would call standard storage, NFS, CIFS, mostly NFS all NFS v3, mostly CIFS v1 for sort of reasons I won't bother you with. 10 petabytes worth of Lustre. Sorry, you can all see this up there. iWads is a big thing for us. Hands up anyone who knows what iWads is, by the way. 3, 4. Okay, wow, that's pretty good. Okay, can you come and talk to me later, by the way, because I'm very interested in arranging iWads Federation with people if you want to be doing bioinformatics stuff. So come and have a chat with me later. So iWads is an object store before object stores were sexy, if they are indeed sexy, and this, most of this has to be in some way replicated or something similar. Now, we don't back most of this up because we simply can't. That picture up there is one I took with my, I would say smartphone, but my phone, through the grill of our SL8500 tape library. And it came out rather well, I thought, but it's It's one of these fairly large tape libraries. Again, this is on site. So one of the challenges we have is disaster recovery, replication. The more copies we have, the more copies we need to keep on spinning disk. So we have to be careful how we replicate, what we replicate, and have that discussion with the scientists. Okay, so another challenge we have, so I don't know if people can see, the important thing for me to draw people's attention to on this slide is the DM number, or the number of LUNs. And on the right-hand side, you can see it goes all the way up to 160. This is a GNU plot chart that I put together of IOStat output when I was trying to find out why a particular iROD server was having fiber channel errors, because the fiber channel errors just said it's on this port, which didn't tell us which LUN it was. So we had to try and work out from that which particular LUN it was. 160 of them. This is the McHugh size over time. So which one was basically backed up, was trying to give us an idea of why we're getting these errors coming through. So having multiple systems with 160 LUNs on it. Now, I don't know how many people know about fiber channel here. Sorry, multipath. Yeah. Okay. So on systems we were using, they had 16 paths for each LUN. So if you think 16 paths for each LUN, 160 LUNs, sometimes booting that was interesting. And when I say sometimes, I mean always. So managing that can be quite a challenge, managing that kind of data. So to move on to the kind of experiences we've had in doing the testing for things. The first thing that we had, well, the first thing, so one of the problems that really sticks in my mind, is one of the kind of defining things, is that we had a storage system under test. It was fantastic, multi-tiered, automatic tiering, so it moved blocks of data up and down between things. So you notice I can't mention a vendor's name, but if you know what vendor, there's not very many vendors that do that. And all this worked fantastic. It had a great GUI, it had an API, it had a CLI, it had decent metrics, decent monitoring. All of this is fantastic. The problem was we just couldn't get it to go fast enough. When we run our test metrics on it, we'd run this, so first of all, we provision a LUN from SATA, okay? Run some speed, okay, comes back this much. Destroy that LUN, create a LUN on SAS. Well, the speed, that's the same speed we were getting off the SATA. Hang on, okay, right, let's do the SSD. That's the same speed we were getting on SATA. What? So we went back with the vendor, and initially they said, you're just not pushing it hard enough. So we put more test hardware in. We put different kind of equipment in, kept running these kind of things. And it's only in the last couple of weeks when the vendor suddenly realized that all of a sudden, we said, we weren't going to buy this because we can't make it go fast enough. That all of a sudden they started putting experts in and flying people over, and we had lots of in-depth technical discussions, and the database team who we were going to be buying this for were involved in a lot in rerunning their tests and tweaking this and tweaking that. But ultimately, we couldn't get an answer over why the tiering got different, got the same speed no matter what we threw at it. And this led us to a lot of questions, and a lot of things that we didn't know. So we didn't know if it was the vendor's equipment or our test harness or the equipment that we were using. We didn't know we didn't know whether with the fiber channel network, all these kind of things that we didn't know, which led to a lot of information about what things we needed to get, what kind of metrics we needed to get, what kind of information we needed to pull in. And it led to quite a sticky situation with the vendor, because basically it was an us versus them. We said it didn't go fast enough, they said we didn't push it hard enough. And we said, well, they should better tell us where we were going wrong, because they had access to all the systems, they had access to all the data, and so it got quite sticky. And in the end, one of the reasons we didn't buy it was simply the fact that they couldn't tell us what had been going wrong. And we knew that if they couldn't tell us that when money was on the line, they certainly wouldn't be able to tell us that 3 months later, 6 months later, when we were phoning them up going, why do none of our databases go quickly? It was actually useful from that point of view rather than just painful. So, by the way, this picture up here is the only picture I could find showing recursion. It turns out it's really difficult to get pictures of recursion that don't use vendor images. So see earlier can't seem to be displaying a particular vendor. So scripting stuff. I probably don't need to tell anyone in this room, especially if you've been paying attention over the last few days, that scripting things is good. So it's automating as much of the tests as possible, but just be a little wary. We had one system that, and the vendor said, we can support 1 million snapshots. Awesome, I said, and wrote a script to generate 1 million snapshots, 1 per second. It was going fine, running on generating the snapshots. The GUI fell over about a day or so in. It was a Java-based, hadn't been written to handle that many snapshots. The CLI, bless it, kept working, so it's another good reason to have a CLI API interface into the product. And eventually, I called up the vendor and said, so, you know, it got to 250,000 snapshots. That's pretty good. And he went, 250,000 in one directory? Yeah, that's what he said he could do. No, we went 1 million snapshots in total. It's spread across multiple different directories. We didn't mean in one go. So, oh, he probably should have told us that. So, you know, do check with the vendor and do ask. But the thing I took from that actually was, A, having APIs and CLIs was really good. Don't just rely on the GUI. And again, I shouldn't have to tell people this, I expect. But also the fact that, frankly, it didn't break. It wasn't designed to do what we did to it, and it still did it anyway. So in that case, that was a successful test. Unfortunately, that was pretty much the only successful test we had with that system. So the other thing that we were finding was that specifying what we were going to do with the storage system was really important. Designing up front what we were going to use it for, telling the vendor that, and getting hardware in that matched what we were going to do with it was really helpful. Did anyone see the Cloudera talk yesterday about pitfalls of testing big data? Yeah? One person, 2 people, okay. So one of the things they mentioned there is how a vendor can skew things is by providing hardware that is utterly it's completely different from what you'd actually get in production, or something that would be utterly unrelated to what you'd actually be able to afford. So having that conversation early on is quite helpful. But in one case that we were doing, it wasn't helpful because my boss had specified one thing, the vendor had specified something else, and we were told to test it based on a third specification. There was no way to win that. The hardware couldn't win, we couldn't win, because whatever we tested against wasn't quite the right setup for it. So trying to match up what you do and where you do is really important. Again, sounds obvious. If you went to the project management talk this morning, that's one of the things they go through. Know where you're going to begin with. So beta hardware, this is the bane of my life. So because we want to store this vast volume of data, and quite often when we get the storage system in, it stays a long time, 7 years, 8 years. Quite often we buy more of it if it works out well, multiple petabytes worth. Lots of vendors want to get their kit on the floor. Particularly they want to get the kit in the front row of the data center that has a big glass window that hundreds of people walk past a year and get demos of the data center off. So everyone's keen to get in there. So what they tell you is, we've got this new thing. Can we come and, can we send you some test kit? And that's fine, but what we were finding was they were sending us stuff that was pre-production. And that wasn't fine, because what we were finding was we ended up being their QA department. We tested this, it broke. Oh, actually, we hadn't tested this. We tested that thing, it broke. Well, we hadn't thought of doing it that way. And after a while, you do kind of think, well, what are we doing here? Are we doing this for your benefit, or are we doing this for ours? So just to be a little wary of that. It's fine if you're going to put the beta system into production. Don't do that. No. But if you're not, wait for the production code. Around that as well, quite often I say to vendors, the test will usually take about 3 months, and we'll go through 2 revisions of your software. And they say, no, that won't happen. It's about right. We find some bugs, they ship some fixes, we go through the whole process. So this is one of my favorite stories of that. We were testing a system that worked out quite nicely. It's not this system, by the way. If anyone recognizes the vendor here, it's not this one, okay? I should say that now. But we were testing a particular vendor's equipment. It was going quite well. And we started doing the negative testing, pulling cables out left, right, and center. And we noticed that when we pulled out the disk enclosures, the interlocking cables between the disk enclosures, that the system sort of said, no, I'm fine. Yeah, it's all right, it's fine. I'm pretty sure not. So we had the conversation with the vendor, and it turned out they'd never thought of monitoring the disk enclosures. So an entire rack full of 60 disks in 4U chassis, 10 of these things, and they literally didn't know whether or not these things had power supply problems, interconnectivity problems, anything like that. They could tell you whether the disks were okay or not, because that was at a higher level, but they couldn't tell you anything within that. And that was interesting, and it really brought home the fact that pulling cables out is really quite helpful. And this particular vendor had been very nervous about us doing that. And when we said to them, these are some of the tests we're going to be doing, they said, you can't do that, you might break it. And it was like, look, if we pull up a power supply out and it breaks, that's instant fail, right? This is a hot plug power supply. I should be able to pull it out. If I can't do that, we've already got problems. But they had issues then over warranty, and if we actually did break it, who would pay for it? And that, again, it could have got a sticky situation. Fortunately, the vendor were fairly sensible. Unfortunately, we talked to them about this beforehand, so we got to have that conversation before the lawyers got involved. So that was always nice. So based on the experiences, we tended to change what we were doing over time. Obviously, we had to change the particulars of what we were doing based on the kind of storage system that we were testing. But we also evolved kind of how and what we were doing as well. So we initially started off with a test framework that one of my colleagues wrote based on our LSF batch scheduler. And this allowed us to use a chunk of the farm that we were... Farm, sorry. People know what I'm talking about when I say farm? I don't mean pigs. Yeah, okay, so a compute farm is what I mean. So we could take a chunk of the compute farm out and just exclusively use that for the test runs, so that other people's jobs running on there didn't skew the figures and things like that. And we had this set up so that we could specify we wanted to do this amount of streaming I/O from this number of blades, we wanted this number of random I/O from this number of blades, we want a bulk write, we want a bulk read, and all this kind of thing like that. And it was great, it worked very well. But the problem was, every now and again, a vendor would say, oh, could we get a copy of your tests? Sure, we'd say, and we'd send them over this hideous tarball thing that basically, I'm pretty sure they took one look at and kind of went, what? How do we get that working? Because it was no way was it designed for somebody else to get up and running. So we then switched to using VDBench, which came out of Sun, now Oracle, because it had a configuration file. You could give them the configuration file, and with VDBench they could then run exactly the same test. They could see all the same parameters, what size of files you were creating, what the different block sizes were, how many different runs you were doing, how many machines you were using, all this kind of stuff like that. So if you provided the VDBench file and the specs of the hardware you were using for the test, they could have a chance of replicating it. So, well, again, we tried different sizes of things. Big files sounds pretty obvious. Genome data is large. It's multiple gigabytes each file. Each of those files are a bit like a tar file. They have an index in them. So people quite often they open the file, they read the index, they seek to gigabytes into the file, and they read the bit that they want, and then they close the file again. So that's a fairly normal workload for us. You do a lot of that, it starts to exhaust the memory of the system it's running on, maybe the client it's running on. So there's kind of issues around that. We wanted to make sure that it wasn't our test hardware getting in the way, and that it was doing a right test of what we were doing. Small files and zero-length files. Wonderful comment we had a while back. We were talking about some of this to the senior faculty, and we said one of the things we do is test for 1 million files in one directory. And one of the researchers went, that's so stupid. No one would ever be so stupid as to do that. At which point the person next to him said, shut up, that was us. Yeah. And it's also zero-length files. It turns out object stores are really bad at handling. It's a nice question to ask your object store vendor, how do you handle zero-length files? Because some of them do, and some of them just, why would you do that? And it's a valid question, why would you do that? But nonetheless, they need to be able to handle it, because sometimes that will happen, particularly if you've got something that is very metadata heavy. It might be important that you have a zero-length file with a lot of metadata. Also, I presume people know as well that you can't just have one computer with one stream. There's only so much you can get out of that. You need multiple streams of this. How many streams, how many CPUs, CPU contention, all this kind of a thing. So you need to be aware of what you're doing there, that you're not stepping on your own toes when you're doing that. And again, that's something that came out of the whole, we can't make it go fast enough. How are we doing this? Are we doing this? Are we doing it the same as somebody else? Are they using representative hardware? So we changed, as I mentioned, the software from handwritten in Bash, LSF submission stuff to VDBench and running, basically manually kind of shepherding it ourselves. And we changed the procedure on how we were doing it from a lot more inclusion with people, a lot more discussion than just running some tests and saying pass, fail. We also, as I said, we started sharing with the vendor increasingly more and more. We start off by saying, no, we will not tell you our testing plan. This is secret, otherwise you will optimize your hardware for our testing plan. And then after a while, we realized they weren't doing that. And actually, this is causing them problems to be able to meet our test plan. It was causing us problems because we said, now we're going to do this with it. And they went, but we didn't design it to do that. So it actually became increasingly helpful to be able to share this, because in the later evaluations I've been doing, you get half the evaluation out of the way by sharing the list of tests you're going to do and having a chat with the vendor. You can do that over Skype, you can do that over the phone, you can do that over WebEx, and you can go through, quite often with some senior people in the organization, all the things you're going to be doing, the likely problems you're going to run into. You get half of the thing done before it even turns up on site. So, negative testing, we'd always been doing some testing of things, but every time we had a test that failed, we made sure we included that in the next time test, so that we're always increasing the test coverage. This is fairly standard test-driven development, right? Every time you have something that fails, you put a new test in for it. Only we're doing storage development or testing in this sense. By the way, this picture I found for negative testing. I was wondering whether or not he's holding the other hand up because he's just broken it by doing that again. I'm not entirely sure. There we are. So anyone know what this picture is, by the way? Monitor lizard. So yeah, anyway. So monitoring of test systems and clients. Just having the question with your vendor, how can I get your I/O stats out? Storage systems, in my experience, are shocking at being able to tell you what it is they're doing and what's going wrong. If you're lucky, you'll be able to get SNMP out of it, and very likely you won't be able to get any depth out of it. Being able to get I/O queues in flight or something like that is just unheard of in most cases. So being able to know what you can get out of it, graphing as much of that as you can, rather than the vendor's tools. Most of the vendor's tools I find are point in time. You can look at them and watch what it's doing right now, but if you want to see what it's done over the last week or so, you need to have been graphing this yourself. And hopefully the vendor will have included something to do that. We've still had vendors that quite simply didn't understand why you'd want to do this and gave you a Flash-based GUI to do this with. That, yeah, okay, it went back in over time a little bit, but you could never ask it the questions that, you could only ask it the questions that the development team had thought of. You couldn't ask it your own ones. So again, there's been a lot of talk on metrics and things like that. I hopefully won't need to go through any reasons why you need to do that kind of thing or what kind of things you want to do with it. But the more you can graph of both the storage system that you're testing and also the hardware that you're using to do the test, the better, because this is the thing that we found out from the you can't make it go hard enough. We then got into a situation with the vendor where they said, oh, you weren't putting enough across the fiber channel. Well, we didn't see the system sitting in I/O wait. Well, this going the whole back he said, she said. I mean, we didn't have any stats, any graphs to be able to say at this time we were doing this test and the I/O wait was here. At this time, on the storage system that it was here. All these kind of things. So being able to find that out was quite tricky. But all of this has lead time to set up. It's not something that you can do very quickly unless you've got all this kind of infrastructure set up beforehand. We also started doing some project management. Initially, it was just some stickies, not quite that bad, but nonetheless. And over time, it became the first one I did. When I came in and started, the storage evaluation had been going on for 2 years. So that really wasn't particularly ideal for anybody. So we started saying, okay, we're going to start doing the test and we're going to finish at this point. So we're working out what tests you want to do, plan them out with the vendor, plan them out when they're going to finish, have the project plan, but if you can, have it where both sides can see it and how you're getting on with it. We used Liquid Planner for this with a couple of vendors, and that was really helpful. Being able to say, okay, these are the tasks you should be doing, and this is the time you should be doing them on. These are the tasks we should be doing and when we're doing them. And you can see as they start getting ticked off, percentage complete, stuff like that. It allowed them to be able to go back to their management and say, see, Sanger are doing stuff with this £1 million worth of kit, we ship them, and this is how far they're getting, this is when it's likely we can have it back, and things like that. So, Out of all of that, what lessons have we learned out of it? Well, I've kind of mentioned some of them already, but just kind of pull them out slightly. A good vendor relationship is really crucial. Again, we can't make it go fast enough one went really downhill in the last few weeks, and it was really quite adversarial. And we started getting to the point that there was cover your ass going on and all this kind of thing. So it got quite tricky. The more you can talk to your vendor, the more you can both be in it together, the less this kind of thing is going to happen. But also the more they will tell you, the more chance you have of meeting people. If you're friendly and approachable and reasonable about talking with them and about talking with the people that come on, they make more resources available to you, including quite often some of the engineers and developers who actually wrote the software behind things. I've had a number of conversations about why things didn't work with the person who wrote the software. And that's always very interesting and elucidating, because they've always thought of stuff that you haven't, and they've always done it for a perfectly good reason. And sometimes you can give them the additional use cases they hadn't thought about because you're coming at it from a end user perspective, and they're thinking of it from a I want to make the bits land on this part of the disk in the most optimal way. And that's sometimes why vendors have also wanted to come to us and do evaluation, because we try and give fairly good feedback on things. So the other thing that we found is that you can learn new technology. But by the way, you know the famous quote about Microsoft and Bill Gates saying 640K is enough for anybody? You think that kind of thinking is dead? I tested a storage system just recently where we ran into almost precisely the same thing. An engineering limit for how large a file size was going to be was put in back in the days when files weren't likely to get that large, 5-6 years earlier, and they just hadn't twiddled the particular knob to change this. As a result, when we started throwing multiple gigabyte files at it from the storage farm, in lots of them, so we were throwing, it was 16 times 32 at the time, big chunks of them coming in. They literally couldn't process it fast enough. We're taking that as a race condition that actually the storage systems are having problems. And the entire system went off like that because it was distributed and all of it was communicating with each other. And it was saying, well, this one's high, this one's high, this one's high, this one's high, this one's high. And it was the only outage, the vendor tells me, that they have ever had in this way of this system. And this is something they told me is fairly mature. They've been doing for a bit. But nonetheless, we managed to get it completely to turn itself off. But in its defense, no data was lost when doing it. We just had to restart the jobs to do that. So there's nothing new in tech. But having said that, just by doing these evaluations, I've learned an enormous amount about all the about new types of technology that are coming in. Different disk types, different types of storage types, different types of communication, or different types of APIs, all these different types of programming languages in some cases to better drive the APIs. There's all kinds of things you learn in the larger ecosystem of doing this kind of testing. So Ben Rockwood's talk earlier today was mentioning a lot about kind of things you can learn and kind of what sysadmins are kind of changing to be and kind of things like that. And really, when it comes to the turtles all the way down approach, storage is very much like this for me. Someone's got to manage this storage at the end of the day. Even if you've got all your data stored in AWS, that's sitting on a hard disk in Amazon's cloud somewhere, which means somebody is looking after that disk. The talk we had right at the beginning of LISA was about somebody who is literally managing that disk, right? So, if you're testing the storage system, you're likely to be that person. The amount of tech you learn about all these different things. I thought when I'd be doing it, it's just an NFS system, it's just a sys system, they're all the same. Actually, lots of different things. There's ZFS, there's all these different storage systems, ways of doing things, object-based systems, lots of stuff you've learned just by doing fairly basic evaluations of things. You also may fix existing things when you've been doing this, partly from the lessons you've learned about all the new technology you've learned, but in one particular case, we actually had a particularly large vendor. We had a lot of our what do they call them? Blade chassis. A number of blade chassis that were having a lot of fiber channel problems. Pretty much random, it doesn't matter whether it had I/O based on it or not. It was having I/O issues going through. Random, sometimes it would have huge amounts of I/O, sometimes it wouldn't. Couldn't work out what the problem was. For a year, we've been working with the vendor. What's the problem? Traces back and forth, switch configurations back and forth, operating system lists back and forth, or firmware upgrades, which turned out to be a horrible nightmare on the blade chassis back and and forth. You know, we had people come on site. It was a complete nightmare. While we were doing that, towards the end of it, we had one of the storage vendors come in. We plugged in with the storage kit, and screaming errors, everything fell apart. It was terrible. So the storage vendor kind of went, well, that's weird. That hasn't happened before. So they brought their technical people in. And they did some analysis and said, look, your SAN, it's got these problems. You know, you're doing soft-based zoning and hard-based zoning. You've got switch firmware that, oh my God, you know, that was done with the dinosaurs. You've got to upgrade to this version because it fixes these issues. And they went through a number of things like that. So we upgraded these things purely so we could get the storage system in for test. And all of a sudden, all these other problems went away. So we took great pleasure in going back to the other vendor who'd been working somewhat recalcitrantly. That's difficult to say. So, with some regret with us over time for the past year or so. And we said, oh no, we fixed it. Other vendor, their major competitor, and told us what the problem was. That was a fun conversation to have. So management, managing the system, managing the people that are working on it, managing the people who are the contractors coming in to help you with it, all this kind of thing. It's not a dirty word. Someone needs to do it. Someone needs to look after it. Possibly not by strangling people though, but yeah. Project management is something that comes out of that. But project management doesn't have to be the full waterfall, full agile. You don't need scrums, all this kind of thing. You can do that, and it works quite well. But you don't need to do that. Sometimes it can be just this, a conference call once a week, and this is when we think we're going to be finishing. Quite often, that in itself is enough to keep everything on track. If everybody is constantly talking to one another and saying, this is where we've got to, this is how we're getting on, these are the problems we're having, you're on holiday next week, we'll do this test this week rather than next week, those kinds of things, they're pretty basic. But actually, they mean that all the delays that would otherwise come about from this thing not quite happening and that thing not happening, this person not realizing, it's all part of their communication. Communication isn't just external, though. It's also internal. As I mentioned before, the use case is really, you know, when the management came to us and said, we want to test this system, having the project management methodology to be able to say, what's your use case? What do you want us to test? You know, how much money have we got to spend with it? You know, what else do you want us to be doing at the same time? Do we have those conversations? I learned through, as I said, through pretty much bitter experience, that if you don't have those conversations up front, you can never have a successful test because you're never going to know what it is you're going to be testing. You're never going to know how you're going to be getting to it. Okay, out of that, what kind of tips and tricks have we learned? This is a trick, by the way, in case you're not sure. Can anyone see what's unusual about that photo, by the way? Yeah. Okay. So to use somewhat management speak, begin with the end in mind. What are you going to be using this system for? How are you going to manage it? How are you going to monitor it? What level of 99 nines do you want from it? How quickly do you need to bring it back? What kind of response do you need from the vendor? Can you test that? Do you have a failure in the storage system when it's live that you can see how well they respond to an outage on the system? And finally, how are you going to hand it over? And there's two aspects to that. How are you going to hand it over to your, say, ops team, or your colleagues, but also, how are you going to decommission it? This has bitten us somewhat. There's 7 petabytes I mentioned of NFS and CIF space. We've migrated all of it to a new storage system over the past 18 months. And that was on a system that had all the tools to do this. Between different systems, had APIs, and we could script it. It still took us 18 months to simply move that amount of data. And that's optimum best case. When we have to do our syncs and restart them, and multiple streams and all those kind of things like that, it gets really nasty. So try and think about that thing up front, talk to your vendor about it. Negative testing is led to the most interesting level of conversations that I've had with a vendor. Partly, oh my God, you can't do that. But also, pulling cables out, seeing what happens. And cable pulling, as an example of negative test, is a really good one. I've had one storage system that I pulled out all the 10 gig Ethernet from it, I pulled out the management, I'm sitting there literally with it dangling in my hand, much like that guy is. And the monitoring system is going, no, it's fine. Everything is fine. Pretty sure it isn't. Our cluster is perfectly talking to one another. Everything is still up. No, pretty sure it isn't. So we had the conversation with the vendor, and we found out that, yeah, that our cluster system for high availability only checks once every 10 minutes. Anyway, but again, pulling out pretty much any cable that you can plug in, try pulling it out. Try doing it under load as well. That's quite often changed the behavior. Doing things under load, particularly failing over. if you're going to be managing the system, try managing that under load. If your management is built into the unit, what happens when you saturate the 10 gig interface, for example? Can you still manage it? Can you tell it to fail over to the other head because it's being hammered? All of those kind of things like that. Again, the kind of things that you're likely to face at, as quite often people have said, at 3 in the morning, or when users have done something really quite spectacular to the system. These are the kind of things you want to think about before you buy the system, but also before you put it into production. And disk failures as well leads to a lovely set of conversations with the vendor about what is a disk failure. Is pulling it out of the enclosure a disk failure? Because that's not normally how they fail. How can you get them to fail like that? Talking to the vendor and seeing whether they understand that and having the conversations with them can also be quite illuminating. But do also try doing this, because the chances are you're going to get it wrong with the new system fairly early on. Once you're an old hand, you're probably not going to be pulling the wrong disk, probably. But fairly early on, if you've built a RAID 6 system and one disk has failed and you've pulled that one out, only that wasn't the one you think it was the other one, the other parity disk. That's the kind of thing that's likely to happen early on. So test what happens when you do that, and test how the vendor responds. So I put together some useful links over time. It's about 3 months back now. Pretty much this LISA's talks, go and watch all of these, because most of them cover a lot of this. I would say go and see Brendan Gregg's talk, but he's doing that right at the moment. So thank you very much for turning up as well for this. So I'm not quite done yet, hang on, but thank you very much. Just to sum up, when you're doing the storage test, what things to think about. Think about what you need to report on when the tickets come in, particularly when all the metrics come in, things like that. When people are complaining, can you get the information you need? Can you sort it out? Plan what it is you're going to be testing related to the use case of what you're doing, and share that with the vendor that you can be doing it. Share it with your management, with your colleagues. Make sure that many eyes on the problem will give you a good view of things. Script as much as you can, and graph as much as you can. The more of this that you can do, the more that you can document. And finally, that's it. Thank you very much. I haven't given the slides to the presenters yet, so I'll be emailing them later on today, so that'll be going out. But do email me if you want the slides before then. Yeah.
Hey, just curious, you said you're using DB Bench or VD Bench for your load testing?
Yeah.
What do you do with an application to actually find what that load test distribution should be? I mean, how do you model it?
That's an excellent question. The honest answer is we have actually stages of how much we're going to throw at it until we find it creaking. We did try initially using exactly what the scientists did and rerunning scientists' workflows based on what they were doing on the cluster at the time. And that was actually quite helpful in terms of this is actually what they do. But we found that didn't take us to the very end of what the system could do. So by effectively having an artificial workload of as much we could do, as big as we could do, actually tended to push the system a bit harder. But if you can run real-world use cases as well, that's also very helpful. We were able to have good conversations with people saying, this is what this system we've got in production does, this is what your system does, this is where the graphs diverge, actually is really quite helpful. But we've also found, as I say, that by pushing it way more than it's designed to do, you get to the edge cases of what the hardware can do, and then you can have the conversations with the vendor. Because your customers, in our case, our students and our faculty, will always push it in ways we hadn't anticipated. So if we can get to the envelope in another way, that'll get us some way of that.
Thank you very much.
Thank you.